So we're looking at cybersecurity over here, understanding the concept of CM and SOAR, talking about advanced tactics and techniques. What you're looking at is a folder that contains critical files to deploy Terraform infrastructure as code to Azure. It's pointing at some resources and some key components it needs to make that. And then we have one of the files that should actually contain the actual deployment. What are you trying to deploy? We can see I have two virtual machines running over here. I'm going to say, show me information for an IP address 10.0.0.5. And that is me trying to ping the second computer server. And it starts to bring in different information. We talked about our universal folders in Splunk. It's performing audit actions. The deployment has been completed. That is pretty much what the security posture here is talking about. I can see if there were any attack paths, I can find them over there. All of those key items we talked about. Initial access, execution, persistence. Thanks everyone for joining the S.H.I.F.T Hackathon by SCARStack Solution Inc. I believe everyone can hear me by now. So basically the S.H.I.F.T Hackathon right here is meant to bring everyone together for us to collaborate, for you to learn new technologies, for you to also bring in a discussion environment where if you have questions or you have a similar story or some sort of relative story to share about what you're learning or what you're seeing or what someone is presenting, feel free to do that. Now, there is a little bit of an error over here with the website naming, but usually the website is scarstacksolution.com. So if you come over here, you see it is www.scarstacksolution.com, and feel free to reach us on our business line. Give me a quick second over here, which is 469-325-4670, in case you want to jump into a full IT training. Now, before we kick off, very, very important and relevant to let us know that SCARStack Solution offers IT trainings, practical hands-on IT trainings in many six-figure areas, including the multi-cloud engineer, the cybersecurity, and the multi-cloud engineer actually covers Azure, AWS, and Google Cloud Platform. We also have our cybersecurity SOC analyst that governs around an IT training targeting the CISSP certification, the highest and the best certification within the cybersecurity space. We also have Azure Cloud Solution Learning, AWS Cloud Solutions, DevOps, Data Analyst, Scrum, Cloud Security, including software programming. So a whole lot of interesting areas to get an IT training. The IT trainings are practical, hands-on, and very, very serious. They put you into that six-figure space and give you real-life experiences, all right? So based off that, let's kick on because we've lost some little bit of time, so we jump into this directly. And so the S.H.I.F.T stands for SCARStack Hackathon for Innovation, Freestyle, and Tech. This is going to be a monthly series where we're going to be choosing different IT areas and IT fields and IT professions, where we'll talk about different tools, technologies, skill set, show you some practical notions around them, as well as theoretical understanding so that you have a very solid grasp of how these technologies work within the IT field. This program is also designed for people of different areas, including students, career changers, people looking to change their career, tech professionals who are already in tech but are looking to elevate or go beyond what they are currently doing in the tech field, as well as enthusiasts, people who are trying to see if they're going to jump into IT and they want to just, jump in a little bit to see what it's all about, all right? And so that's what that is all about. And so why the S.H.I.F.T Hackathon? There are so many advantages towards joining the S.H.I.F.T Hackathon. One of them, hands-on collaboration. You get to collaborate with other people who are either presenting, speaking, or even asking questions. You also get to sharpen your skills by being exposed to new technologies, including new improvements in some technologies that already exist, such as Splunk for cybersecurity, Terraform for DevOps and infrastructure, GitHub as well for DevOps, and then Microsoft Sentinel, which can also cover cybersecurity and cloud security. As you see, there's a whole lot to learn. There's also the project-based learning, where you're able to build mini projects, simple projects, at least at the beginning, based off your experience and your learning curve from this S.H.I.F.T Hackathons. You also get the opportunity to network and connect with other people, either from the guys who are speaking or presenting or other people within the group or within the particular hackathon that you are attending. The best part, it is free to join. You get to easily learn, collaborate, contribute, and also grow without any financial concerns. All right. So this is our very first one, our very first hackathon for the month of July 2025. And typically these hackathons are going to happen almost at the end of every month. So very, very interesting. These are the topics we're going to be covering today. We're going to be looking at cybersecurity, DevOps, cloud security, and then we'll jump back again to cybersecurity, looking at network protocols. We're going to have a solid understanding of what IP addresses are, what network protocols are, what port numbers are, and so on and so forth. And then we'll top it up with what security groups are from the perspective of AWS and Azure. We also look at other cybersecurity tools such as Wireshark and Nmap. And then we'll finally top it up with cloud security, talking about something we call EDR, endpoint detection response, using Microsoft Defender. So let's jump into the very first part of today. So we're looking at cybersecurity over here, understanding the concept of CM and SOAR. Basically, CM stands for Security Information and Event Management. It's basically a tool that we use within the cybersecurity or cloud security space. To do what? We use that tool as a centralized system to collect security data from various devices, various servers, various applications, and as well as various users within our IT space. And CM is able to analyze those data to realize or do what? To filter out security concerns, put them into logs in real time, and what? Alert us on those security threats or incidents. Hence the reason why it says it is able to detect and alert security incidents. And so over here, we have some of the core functions. We can also create dashboards and reports based on different types of threats, severities, or real-time alerts that we are receiving within our tools or applications that are performing CM operations. So let's jump into the next thing over here. So we talk about SOAR. Now, SOAR is very closely related to CM. In fact, most CM tools, you end up seeing them also being SOAR tools. SOAR, called SOAR, is Security Orchestration, Automation, and Response. It works closely with CM because if CM is that tool that is able to collect and aggregate security data and log them and alert us, SOAR, which is Security Orchestration, Automation, and Response, is that other tool that can then automate the way we want to respond to those incidents or threats, be it in the sense of quickly creating a ticket for us or escalating that issue or performing certain automated actions to resolve some of the simpler security incidents and threats. SOAR has that capability to deliver that. And that's why it tells us that it is a solution designed to automate and orchestrate incidences that we receive via our CM tools to what? To respond to them using workflow patterns. And so it can help our SOC team. And whenever you hear me say SOC, that is our Security Operations Centers team. This is used to describe in large proportion or generally the cybersecurity or cloud security teams within an organization across different industries of the workforce. And so it helps our security team to achieve a few great things, such as responding faster to incidents that they receive via CM, reducing the need to manually approach or work on tasks. So as we go down over here, we look at some of the tools that we use within the cybersecurity or cloud security space for CM and SOAR operations. Some of them, number one, Splunk, very, very important. I was showing us that earlier on. Splunk is a very, very powerful tool. In fact, perhaps the most powerful and one of the most, if not the most important cybersecurity tool. If you want to look at that, you can easily go to any IT job portal, start taking a close look at all of the key cybersecurity or SOC analyst jobs, and I bet you are going to always see Splunk showing up there. Very, very critical. You can use Splunk for a lot of deep searching to search and monitor different servers. As we're looking at this right here, I have two servers right here. A server here called VM1 Network Route East and another server here called VM2 Network Route East PRD. These two servers have been configured to what? To be monitored by Splunk. Splunk now has them within a monitored and interconnected network within an organization. And with this, I can now start monitoring these guys to see if there are any cyber threats, to monitor them for performance, to monitor them for other types of attacks, especially when we're talking about the Mitre, ATT, and CK type of attacks. Again, for some of us who are just hearing about some of these keywords, the Mitre, ATT, and CK is a library of well-known cyber attacks that have gone on for decades on planet Earth. This is the official website. The company itself called Mitre, and this right here, talking about advanced tactics and techniques, including common-based knowledge for cybersecurity threat. And that's why it tells us the Mitre TTCK is a globally accessible knowledge base of adversary attacks and techniques based on real-world observation. And so it captures them into high elevated level of threats. Talking about things like our resource development, defense evasion, credential access, discovery, exfiltration, and so on and so forth. Within each key aspect or areas, they have different techniques that has been monitored through time to see how cyber threat occurs. For example, if you're looking at the credential access over here, we'll look at what we call brute force. Brute force is a form of attack on our systems, applications, websites, web services to hack and get our what? Get our user credentials so that cyber attackers can do what? Can hack into our systems to do what? To get our details, whether they're hacking into your banking account, they are trying to steal your health information or any other type of viable key information. It's a system where they're able to send a lot of algorithms to try to figure out what your username and passwords are. And those algorithms keep mutating once they feel that they're getting closer to, attacking, people's systems, accounts, or thereabout. So very, very important to understand the Mitre, ATT, and CK. And so Splunk does a lot. You can create alerts, reports, dashboards as well too. And so let's jump back into what we're discussing. So when I come back over here, we have other tools like Microsoft Sentinel, which is a cloud native CM and SOA tool as well too, that is within the Microsoft Azure. And Microsoft Azure is a cloud-based solution for using Microsoft Sentinel. And then we have other examples such as the Palo Alto Cortex right there. So a lot of interesting things to figure out about. And so when we look at this, we see what the Mitre, ATT, and CK is all about. It's a framework for adversary tactics, techniques, and procedures based on real-world observation. So that's very, very important. So whenever they are listing all of those Mitre, ATT, and CK attacks, they're actually based on real-world attacks that people have experienced over the years. As you can see, as we go down over here, those Mitre, ATT, and CKs, they have different IDs, and they have different names for that. Over here, we can see that the C0225 talks about the 2016 Ukraine electric power attack, and it gives you a little bit of description about what that attack is all about. You can furthermore go in here to figure out and read more about those details. You see it breaks down the different types of techniques that have been used when it comes to the what? When it comes to our brute force attack. So very, very important for us to know that from a cybersecurity perspective. And so with that in mind, we jump into what we call infrastructure as code. But before we jump into that, I want to know if anybody has any questions so far before we jump into that part. Okay, good. And again, remember, for those who are just joining in, if you have any questions, you can feel free to unmute your mic, or if you want, you can also put your messages in the chat, and then I'll be looking at that periodically to answer any questions you might have. So when we talk about infrastructure as code, we are now in the DevOps space, right? So within DevOps, right, for us to understand the concept of DevOps, DevOps are typically the guys between the software coders or the software engineers, software programmers, and the system administrators or cloud engineers. And the main job of the DevOps engineers, for some of us who are a little bit new to it, is to sort of manage and automate the deployment of codes, including some level of testing before the deployment occurs. And so infrastructure as code comes in as a very integral part of DevOps because it helps to also automate our code projects for us. And so it describes infrastructure as code here as the practice of managing and provisioning infrastructure through code. Now, it doesn't necessarily mean that we're writing code. This is not C#, this is not Java or anything like that. It just means that infrastructure as code gives us the opportunity to automate deployment of IT infrastructures, such as deploying and creating computer servers. So it enables automation. It can also give us the ability to have version control. Why do we say that? If I look over here and I go back to this space and I go to my GitHub account over here, I can see that I have a few things going on over here. Right now, I'm looking at a code repository that has an automated fashion for our infrastructure as code using Terraform. Over here, I can keep tabs of different commits I've made, including other team members. And so GitHub becomes a space that is a centralized location for multiple teams in an organization to manage code from one specific angle. This is almost similar to you managing an online Word document where you and multiple people can collaborate on. You can grab a copy of that Word document, update it, send it back to the central location so that every team member is aware of what the current state of the document is, and each team members can contribute to it. The same is for GitHub right here. It is a central location where we manage code. Each team members can go there to update the code, push it to this central location called GitHub so that other team members can be aware of the status or current status of that code, as well as using GitHub as a central location to deploy that code into a website, a web service, a mobile app, or whatever that code is trying to do. In this case over here, we are using Terraform to deploy different cloud infrastructures. And so if I open up this right here, this is an example of us basically using Terraform manually from Visual Studio Code to make deployments of a computer server to Azure Cloud. Basically, what you're looking at is a folder that contains critical files to deploy Terraform infrastructure as code to Azure. There are some key files here, such as our backend.tf, that holds any backend logic to help us control any type of issues we might have, including what we call persistency. And so when you're using Terraform, sometimes when you're trying to deploy and you have an error, say for example, I'm trying to create a subnet, a virtual network, these are cloud infrastructures, right? Networking components. If I'm trying to deploy them and for some reason I get stuck over here, technically what would have happened is that these items would have been created. And so by the time I fix the issue of trying to resolve this particular IT component that is not working well, if I run this process again, I will most likely run into an issue where it tells me that, wait a minute, I'm having a problem here, I'm confused, I'm having a conflict, or I'm experiencing duplicate resources. I already see this in the cloud. What is going on over here? We then introduce what we call the backend.tf file, where we can then implement high-level script that will prevent such things from happening. Let's take a look at it. When I look at it, this is a very simple one right here. It is using a Terraform instruction here to say whenever you're deploying this VM, because basically this Terraform right here is trying to deploy a virtual machine, which in this sense is a computer server. And so it's pointing at some resources and some key components it needs to make that happen, including where it needs to persist a file. When it persists this file over here, it's going to persist it in a file, a specific file here called the tf.state. What this file will do is it will catch the current state of deployment to say, well, you're trying to deploy 5 things. You've deployed 3 of it. 2 has failed. You fixed the problem with the 2. You are now trying to redeploy this particular item or this particular IT infrastructure. I'm not going to worry about the first three you've created because I can see based off the Terraform state that you've created those first three. So I'm not going to give you an error. I'm not conflicted. I'm not confused. I don't see duplicates. I'm going to go ahead to the fourth and fifth items that failed because in trying to deploy those 5 items, 3 went through, the last 2 did not go through. And so that is what the backend.tf does. We also have other files here in our Terraform, such as the output.tf, that specifically gives us key details about our deployment of our IT infrastructure once that deployment is complete. As you can see right over here, I have a deployment that has been successfully created and deployed to an Azure cloud environment. It has deployed a virtual machine. The virtual machine has what we call a virtual network, which is kind of like the brain behind the virtual machine and allows the virtual machine to communicate with all other IT infrastructures within the cloud, as well as over the internet. It has also created a whole lot of other IT components or infrastructures. And the output gives me the opportunity to show certain information based off the successful completion of that deployment. In this case, one of the things I'm trying to let it show me is the password, to say, I want to know that this password was successfully created after this deployment was completed. I also want to know that the computer server, which we are seeing over here, was successfully completed. If so, show me the name. This is the name of that computer server. So the output folders enables us to output details about something. It's just like someone approaching you and saying, I want to know who you are. And then you tell them, my name is this, my age is that, I'm a male, I'm from here, I'm from there. Simple as that. We also have our providers.tf that carries the general high-level configuration to enable Terraform to know what service provider it is working with. As you can see closely here, we have something we call Azure RM, which tells it that Terraform needs to work with Azure's resource manager. Azure, as we mentioned earlier, is a cloud service provider. And so it allows Terraform to know that it's working with Azure. It puts on all of those configuration needed at that high level. And so we have files like that within our Terraform. And then we have one of the files that should actually contain the actual deployment. What are you trying to deploy? Are you trying to deploy a networking component, a security component, a server component, a cloud storage component, a database cloud component? Whatever it is, you need to create one of the files that you can then name differently that will contain all of the configurations and instructions for that deployment. Again, as we go in through this monthly series of our S.H.I.F.T Hackathon, I'll continue to break down a very easy understanding of what all of these things do. But again, we have a lot to cover. But the first Hackathon series, this is just to give you a general awareness of how some of these technologies and tools work. And so that is what is going on over there. And so if we jump back over here, we begin to understand the importance of infrastructure as code. One of the key importance is rather than us having people go build things from scratch where they have to go through so many phases using a user interface, such as an example, coming up over here to an Azure environment, going to a place like a virtual machine, saying, I want to create a new virtual machine, and then let's wait for that to load up. Now that that is loaded up, you can see I have 2 virtual machines running over here. Those 2 virtual machines, VM1, VM2, are exactly what you're seeing in here. Better yet, these 2 virtual machines, they are interconnected using a concept called application security groups that puts them into a networking environment where they can communicate and speak with each other. And so when we head back over here, if I'm trying to create a new virtual machine right here, and I wasn't going through the infrastructure as code method, I would have to click this right here, the virtual machine. We'll wait for that to load up. Perfect. Before I can deploy this virtual machine, I would have to go through many of these processes to put in specific configuration information right in there. Details and information that I must be very aware of. With infrastructure as code, all of that is brought down to just a script, a file that has specific instructions. Let's take a look at that. If I head back over here to the infrastructure as code Terraform script I'm looking at, when I scroll down a little bit, and I see a part here that talks about creating the virtual machine, it gives it specific instructions. The name of the virtual machine should be this, the username and password to log in. into the virtual machine should be this for the username. Even the password, infrastructure as code leverages scripting to give us sophistication in terms of creating a password. Right here, this password is being generated automatically through a particular script over here. This script right here is giving it a command of what it should put together to create a random password. And then we are referencing that password using the word random password and password right here. And so when I go back over here, I can see the word random password dot password. And then we use a dot result that does what? Accumulates all of the result of the actions going inside this particular action space. And so that is how that works. But you can see that right from this particular perspective, the virtual machine is being created by just words. And then it is referencing other items that have been created earlier on within the script. And so if I wanted someone to deploy this with little to no error, and I wanted them to use this specific configuration to create my computer server and all of the other fantastic networking components that will work with it, I will give them this instruction and I will tell them to specifically change some certain things such as the virtual machine name. Perhaps you already have a virtual machine called VM1. I can tell them, change that to VM2. Change the user admin to Azure user. And those might be the only two requirements I might need for them to change. This makes people's life easy because now that person can take those two changes, make them, and then they can deploy that without having to do what? Go through all of this process of configuring the disk, configuring the network, configuring the management, having all of those instructions and inputting them one by one. Furthermore, based off the fact that we can put all of the resources we want to create inside one script, we can create all other resources that go beyond just our computer server. Within the same file, I can say I want a cloud storage. For some of us that understand cloud storage, right? You use Google, you remember your iCloud with your Apple iPhone. That is a cloud storage where you can store things in the cloud. I can say I want this virtual machine to be able to store things in the cloud. I can put all of those instructions in here. That is totally different from this perspective where I have to line this up. Now, this is not bad. It's just in the tech world, there are often multiple options and multiple agendas for organizations to streamline their business processes and their technological delivery, including considering other key areas like automation and easy deployment. And so another advantage of infrastructure as code when we talk about Terraform is when we use it with CI/CD, continuous integration and continuous deployment. As you come over here, we're taking a look at this guy right here. I'm going to go back to it, click on our code section. You can see that I have my infrastructure as code in GitHub, which has the capability of continuous integration and continuous deployment. With continuous integration, I can use GitHub to ensure that teams have a central location for where our code project is. This same way, I can look at that same file I was just looking at over here, locally on my computer, in GitHub. I can take a look at that file right here. That is the same file that has all our configuration for building our computer server and other IT infrastructures. I can see the name right there that I just changed locally on my Visual Studio Code, including the user admin and even the password we talked about. This process can be automated, documented, so that if anyone makes any changes within our organizations, we know who is responsible for those changes. We can track back our actions by saying, I don't want this version. I want the version I created 3 weeks ago. That is a different commit. So it saves changes. Anytime we make changes to those files, it keeps the different versions so that we can easily jump back to other versions. It uses the continuous deployment, uses a YAML file right there. Right now, I've just opened up that YAML file. This YAML file has the specific instructions for our Terraform to deploy, performing specific actions such as initializing Terraform, validating Terraform, planning the execution for Terraform, and then finally performing the apply that actually deploys this. This eventually deploys our IT infrastructure to what? Our Azure environment right here. So that is how infrastructure as code works. So right now we'll take, I'll pause over here, and I do have a colleague who will be picking up from me over here. So let me just check to see if he's in there. Promise, let me know if you're ready or if you need some few more minutes, before you get ready, all right? So meanwhile, while it's getting ready, I'm getting ready to, waiting to hear from him. We'll jump into some other key areas. So we've looked at some of those things. Now, we talked about a part of cybersecurity that covers us understanding how we can do what? How we can connect components together so that we can monitor those components. If we take a look at that, I can see I have two servers over here. Because these two servers are interconnected using some configurations, some IT configurations, right? Including things like setting up an application security group, setting up a network security group, plugging the application security group to the network security group. I know some of these things, for some of us, it looks a little bit, complex. But basically, we can allow computer servers to connect to each other. You understand? Well, thanks for confirming that, Promise. So we'll kick off that in another 3 minutes. You understand? And so we can allow those computer servers to communicate and speak with each other, such that I can monitor one computer server from another computer server using cybersecurity tools, so that I can know if I have any threat on that computer. I can use things like Wireshark and Nmap to monitor that. And so in this case here, before we kick off into the next segment, which is cloud security, talking about identity and access management, let me show us an example of how that works. So for me to do that, I'll perform an action here, and I will title that V, and then I'm in one computer server. I need to jump to the second computer server. For me to do that, I need to run a certain script command, a very simple script command, and I need to provide the public IP address of the second computer server. And so for me to go ahead to do that, I need to get virtual machine 2, which is a computer server. I need to get its public IP. Now I'm actually seeing that IP right over here. But for you to see, that is 2063.72. If I come back over here and I take a look at that virtual machine, I can see it right here. Select it. I can see the IP right there, 2063.72.76. So I'm going to copy that. I'm going to come back over here. I'm going to paste that right in here. So now I have a command that says mstsc/v and the public IP for it to what? For this computer server to connect to this. Again, remember, naturally speaking, computer servers cannot just do that easily. You have to actually configure that from a network security perspective to make that happen. So I'm going to hit enter on my keyboard. And now I see that a screen has been presented to me to log in into this. It automatically provides me with the username, which is cool. Now I have to provide the password for this second VM. I'm going to go ahead and provide that. And I put that in. And so by the time I hit the OK button, this computer server is going to do what? Automatically log me into the second computer server. So let's go ahead and do that. Now, once it does that, it's going to shut this server down. I'll go ahead and hit the OK. It asks me that it would like to create a certificate for it. I'll say yes, no problem. Go ahead and do that. I'll hit the yes button. And just like that, it connects into the second computer server. It is now showing me the content of the second computer server. I can go ahead to expand this. And right now, I'm inside the second computer server. I can reduce that almost like an application. That's the second computer server right there. I can see it, and I can see its IP address right there. And then if I want, I can just continue with my work over here. Secondly, I can also spy into the second computer using what we call Wireshark. Wireshark is a cybersecurity tool that is used for network protocol analysis, to analyze different network protocols. I can start using this Wireshark to start inspecting what is going on the second computer server. I can actually have them speak to each other as well. So let's take a look and see how that works. If I come back over here, I'm going to expand this a little bit. I'm still inside my first computer server. And then I can hit the capture and hit start right here to start capturing details from each one. I can go over here to my command prompt, which is a feature within Windows. I can do an IP, I can do a ping. So I can try to ping my other server so that I establish some level of communication between them. Let's do that. Let's keep this way, reduce this a bit, bring this out this way. I'm going to say, show me information for an IP address 10.0.0.5. Now, currently, this virtual machine I'm in right now is having a private IP address. Computer servers have private IP addresses. If I want to know the private IP address for my own particular computer, let me actually take this out for now. I can use ipconfig to figure that out. That tells me my own computer server is 10.0.0.4. So whenever you see 10.0.0.4 scroll through here, that is my private IP of my computer server talking with other types of IP addresses. And so that's what is going on right there. So if I want to spy on this, I can come over here. Let's try to figure that out. Let me take that out. Let's say ping 10.0.0.5. And that is me trying to ping the second computer server. I need that. Enter on that. Perfect. So it pinged my second server, and that went through because they are interconnected, right? They are within the same network environment. I can do another one for it again. Hit enter on that. Perfect. Now I can run this over here, and I can say, hey, you know what? Go spy on that guy. And you can see that it's capturing the information. That is my second computer server. That's a private IP address. And this is my own computer server with 10.0.0.4 monitoring and seeing different types of protocols, our different types of network protocols. The network protocols represent transportation mechanisms between components such as network components, servers, webmails, file transfer protocols, and so on and so forth. I can see a DNS, which is a domain name system. I can see ICMP right there, and so on and so forth. These are some of the things it just captured recently. You can see that as it goes on, it continues to capture more. At some point, server 2 is talking to server 4. Server 4 is returning a message back as well too. So very, very important concept for us to understand when it comes to using Wireshark. For us to confirm that this IP address here, 10.0.0.5, is actually computer server 2, which is our second computer server, I can go back over to my Azure environment. I'm looking at my second server right here. I can go down here and I can take a look at the private IP address, and I can see. If I want, I can go to the network settings to further drill and analyze to see what are some of the network security it has in place, including its inbound and outbound. I can go over here. I can see it has two inbounds. Inbound and outbound, when we're talking about network security and network security group, is very, very important. It operates more like a firewall that secures our computer servers by preventing different communication holes that other IT infrastructures can use to compromise and attack our system, as well as access our system. Right here, two network protocol services are in place using a protocol transportation means called TCP, which is our transport control protocol. Over here, the TCP is using port 80 to say, I want this server to be able to host a website. Therefore, I'm giving it port 80 so that it will have access to HTTP. If I want to further go forward, I can say I want to give it HTTP as well too, which will then be using port 443. In this case, we're only saying port 80. But it means we've opened out an outlet in this computer server for it to do what? To host websites. To do that, I will need two further steps. I will host a web server on it, such as IIS. This web server will give you the ability to be able to host websites. Then I can now host websites like CNN.com, Facebook.com. Over here, I'm seeing port 3389. This is using a protocol service of RDP, Remote Desktop Protocol, that allows us to remotely connect inside this VM. After all, based off this port, I'm able to log in into the VM. And so that is how network security works. And this is how it's been implemented as an example in the cloud. So over here as well, too, I can see our private IP over here, and I can see we have a public IP. Now, typically when we have the combination of a private IP and a public IP, where the public IP is assigned in a case where a computer server needs to communicate outside with the internet, and that is totally different from the private IP. This is a concept called the demilitarized zone, or as we call it, the DMZ, that prevents the public IP from exposing the private IP based on the need for the public IP. Public IPs are always optional on computer servers. They're only needed for specific purposes or reasons, such as logging in remotely into the server or hosting websites on our computer server. The private IPs are used for internal stuff within the servers themselves, hence the need, or hence the name private IP and public IP. So I'll pause right now and then stop sharing, and then I have another of my colleague in here, someone that I've trained in the past, with SCASTAC solution, very skilled engineer in cloud security and DevOps, as well as cloud computing. Is going to be taking over and explaining to us another part of cloud security. When we come over here to our documentation, he's going to present his own documentation, and he's going to be talking about this key area over here. Let me take a look. Let me take a look at it. He's going to be talking about our cloud security when it comes to using identity and access management using Microsoft Entra ID. So I'll stop sharing, and promise once you're ready, you can kick off with that.
Thank you.
Sure, no problem.
All righty. So good evening, everyone. So for starters, I'll present myself, and then I'll go into the context, and then some of our session objectives. So to begin with, my name is Promise Wanahidu. Like Ola mentioned, I'm a previous bootcamp graduate. I took the security engineering and the DevOps engineering, and that really helped me a lot on the job. So I'm currently a senior technical consultant at Booz Allen Hamilton, and I support the systems. I help keep the systems running that offer like millions of Americans healthcare through Obamacare. As you saw on the previous slide, I have my master's and a bevy of Azure and Microsoft certifications like AZ500, what else? SC300, that's focused on identity and access management, and that's what I like the most, so that's what I decided to present on today. So for a little bit of context, so the agenda overview. So we'll go over the Azure security fundamentals and shared responsibility model, identity and access management. We'll take a deep dive into that. And then we'll have a live demonstration and talk about some best practices, some key takeaways, and then we'll have a little Q&A session. All right, so to begin, let's begin with the Azure security fundamentals. All right, so so we'll cover that. All right, so to secure anything in Azure, first you need to understand like two foundational concepts: the cloud security fundamentals and the shared responsibility model. So it's a pretty common misconception that when you host something in Azure, then Microsoft handles everything, but that's far from the truth. So while Azure does provide a lot of built-in security features and manages like some of the core infrastructure, like the physical data center, servers and networking, they're responsible for securing their data, identities, and how services are configured. So I guess a pretty good analogy for this would be like renting an apartment. So Microsoft is akin to the landlord, and they maintain the building, the common areas like the pool, the gym, and they also handle utilities. But you as a tenant, you still have to lock your doors, you have to protect your valuables, and make smart decisions inside your unit. So for instance, in Azure, this translates to securing your accounts, applying access controls, and configuring services properly. So responsibility shifts depending on the cloud service model. So for instance, IaaS, which is infrastructure as code, sorry, infrastructure as a service. You manage the operating system, the apps, the configurations, and Microsoft handles the hardware and the virtualization. For platform as a service, Microsoft handles more of the stack, like the operating system and the runtime, but you control the data, the access, and then the app settings. When it comes to software as a service, Microsoft handles almost everything, but you're still responsible for user access and data governance. So no matter what model that you choose, your responsibility always includes identity, access control, and protecting your data. So for instance, like Microsoft Defender, for example, Azure provides a built-in service that monitors your resource for misconfigurations and threats, but you also need to enable it. Uh, some of its features are like interpreting its findings and taking corrective action. For instance, if it flags a storage account being open to the internet, it's on you to fix the exposure. Essentially, like the bottom line is, cloud security is a shared responsibility. Microsoft secures the cloud. You secure what you put into the cloud. And with that foundation in place, we're going to move on to identity and access management. All right, so identity and access management, otherwise IAM, commonly known as IAM. So identity is a new perimeter in the cloud, and what you do is you're controlling who accesses what is one of yeah what's you're controlling like who accesses what on the cloud, and it's like one of the most important defenses that we have. So like one single compromised credential or an overly permissioned user can expose an entire environment, which is why identity and access management is such a core focus. And like it's one of the reasons why I like it, because essentially like you have the keys to the kingdom. If you mess up your IAM, you're I guess like the kids would say you're cooked. So at the center of IAM and Azure is Microsoft Entra. It used to be called Azure Active Directory. So now Entra ID serves as the primary identity provider for Azure and Microsoft 365. It's where users, groups, and devices are created, authenticated, and managed. So when someone tries to access a resource, Entra ID checks to see if they are who they say they are, which is called authentication, and whether they have the necessary permissions, which is referred to as authorization. So also that's where role-based access control comes in. RBAC essentially defines what each identity is allowed to do in Azure. Roles like owner, contributor, and reader, those grant varying levels of access. And that's also where specialized roles for specific services come in. So for more granular control, custom roles can be created with tailored permissions. So if you want to give like a very specific um, role to like a very specific individual, like they only have where they only do one specific thing, then you can create a custom role and assign them that role, which gives them that permission. So RBAC also works different in scopes. So there's a subscription scope, resource group, and also individual resources. So this allows you to apply the principle of least privilege, which means only giving users or services the exact level of access that they need, no more and no less. So for example, if someone only needs access to a single storage account, you assign permissions at the resource level, not across the whole environment. Okay, yeah. So for instance, yeah, like the storage account, you can go into that deploy storage account and give that specific user whatever role you feel is necessary for them to get the job done. All right. So by combining Enter ID for authentication with RBAC for authorization, you can ensure that only the right identities can access the right resources at the right scope. It's one of the most effective ways to reduce risk and strengthen your security posture in Azure. So now on to IAM part two. All right, so here we're going to discuss MFA, conditional access policies, identity protection, and privileged identity management. So even with Entra ID and RBAC in place, identity security isn't complete. So attackers, they can still steal passwords, exploit admin accounts, or log in from unusual locations. And that's where Azure Advanced IAM tools come in. So things like MFA, you've definitely heard of it. So MFA adds a critical layer of protection. It requires a user to verify their identity using a second method. So whether it be a code from an app or a phone notification, or like they send you a text message or give you a call, like those are all second factor authentication methodologies and modes. This even means that if a password is like compromised, unauthorized access is still blocked. So Azure supports several MFA options, like I mentioned earlier, including the Microsoft Authenticator app, SMS, phone calls, and hardware tokens. So it's easy to implement, and it's one of the most effective ways to prevent account takeovers. Now, moving on to conditional access. Conditional access allows you to define smart automated access rules. So these policies evaluate designing conditions such as the user's location, device health, and the user's role, and to enforce additional requirements like MFA or block access entirely. For example, access can be restricted to only company managed devices or flagged if the login attempt comes from an unfamiliar country. Also, conditional access enforces zero trust principles by making access decisions dynamic and context aware. So now moving on to Azure AD Identity Protection. So Azure AD Identity Protection uses Microsoft's threat intelligence to detect risky sign-ins and compromised users. It can flag impossible travel scenarios, leak credentials, or suspicious login patterns. And based on the risk level, it can also trigger automatic responses, for instance, like forcing a password reset or requiring MFA. And also admins, they can receive detailed risk reports and can take action to investigate or remediate. It's essentially a real-time detection system that adapts to emerging threats. Now, onto PIM. So PIM is privileged identity management, and it helps secure admin roles by enabling just-in-time access. So instead of giving someone permanent admin privileges, PIM allows them to activate elevated access only when it's needed and for like a very limited amount of time, typically like 3 hours, just to do what they need to do, get the job done, and get out. It also has optional features such as approval workflow and MFA, and that adds an extra layer of control. So once a task is complete, elevated privileges are automatically revoked, and this reduces the attack surface and ensures that privileged access is tightly managed and audited. So in summary, Azure's IAM capabilities, though, you go well beyond usernames and passwords. We have things like multi-factor authentication to protect accounts, conditional access, enforces intelligent access rules, identity protection detects threats in real times, and privileged identity management secures privilege roles. So together, all these tools, they form like a very powerful defense against identity-based attacks, and which are the leading cause of cloud breaches. So even starting with MFA and basic conditional access policies, an organization can dramatically improve their organization's security posture. Okay, so now onto a little bit of a live demonstration and best practices. So unfortunately, I won't be providing the live demonstration myself. It's a lab that I had watched on YouTube a while ago, and I feel as if it would definitely help drive home the IAM principles that we've discussed. Okay, yeah, but first here, we're gonna go over some cloud fundamentals. Can you hear that? Were you able to hear that?
Not yet. Is it playing already? I think it's playing already.
Yes, it was.
Might have some network audio blocker.
Yeah, sorry, give me 1 second.
Not able to. Okay. And there's probably something there that's preventing it from. You understand?
Yeah, I'm going to.
Way that it should be secure. Here. We'll try to discuss some of the myths related around security for a cloud, whether that be a private cloud, public cloud, how those are Microsoft Azure. As well, we'll talk about some recommendations for securing the cloud at a high level. So let's first review the primary solutions. We have 3 types of hosting solutions, infrastructure solutions for Microsoft Azure. The first is infrastructure as a service. The second, platform as a service and software as a service. Now, there are subsections to those types of solutions in a cloud-based service. However, those are the primary buckets. So infrastructure as a service is where the cloud provider provides the physical infrastructure for your hosting solution. For example, you have all of the data centers and all of the servers and all of the memory and the storage, all of that infrastructure is provided for you and is rented to you as a service. A platform as a service is where there's some limited deployment that is already there, the underlying platform. So for example, Windows or a database solution that's already been implemented as a platform. And then you will be renting services as part of that platform. So it kind of builds on top of the infrastructure where you have the infrastructure plus the platform that are provided to you as a service. The third bucket is software as a service. Now, software as a service is where the infrastructure and the platform are already there, but the software is already deployed on top of that platform. For example, an email solution, Exchange Online, is sold or rented as a service. That software is part of Microsoft Azure, and it's marketed as Office 365. So those are the three primary solutions in Microsoft Azure, but they also apply to other cloud providers. If you're looking at Amazon solutions, you'll find similar type of solutions for the cloud provider. Now, the solution type defines the type of security that we need to implement. And the reason why I mentioned that is because you have different type of solutions that are provided to you, and they have different types of interaction with your data and your resources. Therefore, the way that you need to secure that data and those resources is different based on the type of solution that you use by a cloud provider. So if you have an infrastructure as a service, the security requirements are almost identical to what you're currently doing on premises. As part of your cloud solution is the actual underlying infrastructure, all of the software, all of the platforms, all of the operating systems, and everything that you deploy on top of that infrastructure must be secured the same way that you're currently securing your resources on premises. The same way that you're securing your on-premises solutions, you will have to secure your infrastructure as a service solutions based on the similarity of the deployment. Now, if we go a little bit further and look at the platform as a service solution, the security requirements are mostly defined in the configuration and the deployment of what's going to sit on top of that platform. So if you have a storage solution or if you have a document management solution that is going to reside within the platform that's provided by the cloud provider, all of the security settings that you're going to have to manage are going to be the security settings for that specific software, for that specific tool that you're deploying into the platform. So it will be very specific to that application, and the deployment that you will use for that application is going to have some security requirements around it as well, and you will define all of those as part of your deployment solution. If we go into a software as a service solution, then our security requirements are generally restricted to the way users behave and the available configurations in the UI, the user interface of Microsoft Azure. So if you've got, for example, a application or a specific service that is deployed as part of software as a service, such as Exchange Online, where you're provided with a set of user settings and a set of configurations, the way that you manage those configurations and the way that you manage those settings are going to define your security for that software. So that may be the frequency of a password that needs to be reset, or that may be the way that the emails are going to be retained or encrypted into that software as a service solution. So as we build on to the amount of services and solutions that we use as part of our cloud provider, for example, Azure, then the responsibility or the onus of security is taken away from the administrator and is being implemented and provided by the cloud provider. Now, there are various scales that defines well how much of the responsibility is going to be yours as an administrator of an Azure platform, or is going to be provided by the cloud providers such as Microsoft. So I really like this diagram because it provides a good representation of what it is that you are or are not responsible for. And if you see the least amount of responsibility, so those buckets that are defined in blue are in a software as a service solution. So everything that's related to your clients, to your account management, your user passwords, for example, and how much you want to retain your data, all of those settings are your responsibility. Everything else that's related to the platform and the infrastructure are going to be the responsibility of the cloud provider, Microsoft in this case. So all of those gray boxes, as you see, reduce. Therefore, Microsoft's responsibility is reduced as you go down the scale to infrastructure as a service. If you're on premises, of course, Microsoft is not responsible for any of it, and you're responsible for the entire deployment. If you want to completely or reduce as much as possible your security onus and the responsibility of security configurations, then software as a service is likely to be the best solution for you. An important point to note is that you will always own your data. Everything that's your resources and your data is always going to be the ownership of the client, company, yourself, as part of the solution. So it's very important to understand when your security skills are required and where within the solution you will be required to manage a specific type of security setting. And again, the type of solution that you choose with your cloud provider is going to define the amount of security requirements that are on you.
All right, so in the interest of time, we're going to skip on to the lab.
This is Rian from Must Be Noob. This lab guide is on how to manage user profile information in Microsoft Entra ID using Microsoft Entra Admin Center. When new users are created, only some details are added to that user profile. If your organization needs more details, that can be added after the user is created. A user's profile information and settings can be managed on an individual basis and for all users in your directory. In order to add or change profile information, you must be either a user admin or global admin. Sign into the Microsoft Entra Admin Center. Click on Go to Microsoft Entra ID. Expand Users and click on All Users. Select your existing user. There are two ways to edit user profile details. Either select Edit Properties from the top of the page or select Properties. In this example, click on Edit Properties. The full list of properties appear in edit mode on the All category. To edit properties based on the category, select the category from the top of the page. I'll update the job title information for the selected user. Let's type job title application developer. Just like this, you can edit other profile information from here. Once you're done, select Save at the bottom of the page to save the changes. If no image has been added for user profile picture, the user's initials appear as user profile picture. This picture appears in Microsoft Entra ID and on the user's personal pages, such as in My Apps. On the user's overview page, select the camera icon in the lower right corner of the user's thumbnail. Click on Browse for File. Select the profile picture and click on Open. Select Upload. Wait for a few seconds for user profile picture to update it. Still, you can see user's initials appear as user profile picture. Click on Refresh. Finally, you can see now user profile picture is updated. Click on All Users. You can also see user profile picture on All Users page. In this lab guide, you learn how to manage user profile information in Microsoft Entra ID using Microsoft Entra Admin Center. That's all for this lab guide. Stay tuned for more.
Alrighty, so now it's the last few slides. Alrighty, yeah, so yes, so now onto some of the best practices. All right, so now that we've covered Azure's identity tools, here are a few ways to apply them effectively. So essentially think of this as like a checklist for strong identity security in the cloud. So first, like we discussed earlier, you need to enable MFA for all users. So start with like some of the basics, multi-factor authentication, that should be mandatory, especially for admin accounts. And then security defaults in Entra ID make it easy to enforce. And MFA blocks the vast majority of identity-based attacks. Now moving on to enforcing least privilege. So you grant only the permissions needed for each user or application. Avoid broad roles like owner unless absolutely necessary. And then regularly review and remove unnecessary access. by holding access review meetings. So if there are built-in roles that are too permissive, create custom roles that are tailored to specific needs. Next, you assign roles at the right scope. You use RBAC to limit access as precisely as possible. What else? So then you assign roles at the lowest practical level, such as a resource group or individual resource, to reduce risk if credentials are compromised. Then moving on to privileged identity management. So you use PIM for admin accounts. You do so to protect high privileged roles with privileged identity management. It's up to you to enable just-in-time access and require MFA or approval for role activation. Also, you maintain secure break glass accounts with strong controls for emergencies, but don't use them daily. Next, you monitor sign-in activity and risk. So you enable Azure AD identity protection or regularly check sign-in logs. You set up alerts for suspicious activities like impossible travel or unexpected admin role changes. And then you forward your logs to your SIEM. That's what Olu was presenting on earlier, Microsoft Sentinel, for deeper analysis and incident response. Next, you apply conditional access to sensitive resources. So essentially for high value apps and data, you create strict conditional access policies, such as requiring compliant devices, using Microsoft Intune, blocking access for certain regions, or enforcing MFA under risky conditions. And then you tailor the policies to your organization's threat model. Then, like I mentioned earlier, you conduct regular access reviews. So periodically, you review who has access to what. Use Azure AD access reviews or manual processes to remove to remove stale or unnecessary and overprivileged accounts. This is going to help in the long-term this is going to help in the long term to prevent permission sprawl. And so ultimately, the goal is to minimize the attack surface and stay proactive. So basically, if you only do two things, just enforce MFA and apply least privilege, you've already addressed the major portion. By doing so, you've already addressed a major portion of identity-related risk. So you start from there, and then you build up with conditional access, PIM, and then monitoring your environments as it grows. And now on to some of the key takeaways. All right, so yeah, we've definitely covered a lot of ground. So let's drill into the key takeaways from this session. So if you only remember a few things, please remember these 5 concepts. So cloud security is a shared responsibility. So Azure secures the infrastructure, but you're responsible for the data, the identities, and configurations. So you need to really understand where your responsibilities begin and where they end. Next, identity is critical. So strong identity management is essential. It's of the utmost essence. You use Entra ID to enforce multi-factor authentication, apply conditional access, and monitor sign-in risk because most breaches start with compromised credentials. So you really have to protect those. And then you enforce least privilege. So you use Azure RBAC to limit access, and you assign only the permissions needed and review them regularly to prevent overexposure. And then you leverage the built-in security tools. So you use services like Defender for Cloud, privileged identity management, and identity protection. These tools, they help automate detection, enforcement, and oversight, and ultimately reduce manual overhead while improving security. And lastly, you need to stay vigilant. So you need to stay vigilant. Security is continuous, and you have to be very proactive. So you have to monitor the activity, adapt to new threats, keep up with Azure's evolving features, and then build a culture of security awareness within your team. So essentially, if you apply these principles, you'll be well on your way to building a secure solutions in your Azure environment. So like, even if you're a beginner, like you focus on the fundamentals and you'll already be doing better than many. So remember, small improvements like turning on MFA can have a huge impact.
Appreciate that.
Yeah, for sure.
Yeah, definitely. So to follow up on what Promise was trying to say, you mentioned a lot of key technologies right there, right? You talked about RBAC, role-based access control. Talked about Microsoft Entra ID, the key technology that makes all of these things work within the Azure environment, right? When we're talking about managing identity and access control within the cloud environment, specifically with Microsoft Azure. And when we mention RBAC, the role-based access control, it is the other technology that works basically with Microsoft Azure right? Using Microsoft Entra ID and using another technology called access control to do what? To enable access to specific IT infrastructures within the cloud. Now, if I jump forward to other things I want to talk about, I'm going to show you what that is all about right there. So we just finished talking about identity and access management. I'm going to quickly give you a quick freestyle on what that is all about. I'm going to go to my own page of Microsoft Azure. I'm going to go right into Microsoft Entra ID. Let's let that load up. And you can see there was a presentation that I'll show to you, and you can see a lady putting together users and things like that. You know, we're using that uses a special application called the Entra Admin Center right there that you're looking at right here. And then, but you can still operate on majority of those things within your original Microsoft Azure environment. If I go over here and I click on users right here, it's going to load up maybe 1 or 2 users right in there. I see one extra user right here, Jane Doe, right? Jane Doe has just been employed by a company called Contoso, and they've set her Azure credentials up for her. They've given her an Azure account, they've given her a password, and she's been sent that email, and she now has that credentials. Now, if this was a normal company, it could be jane.doe at, let's say, contoso.com or cnn.com or whatever company that is. As you can see right here, Jane Doe has access to 2 applications. Let's go and quickly see those 2 applications. You can see she has access to Zoom as well too, and Citrix. It means that with our Azure portal account credentials, that's her username and password, she can successfully use single sign-on once it's all set up for those 2 applications we're looking right there, to successfully and easily log in into those applications based off our Azure credentials. Now let's take one step back. When I come back over here, we can see that she's also a part of a group. She can also be added to a group, and those groups can have what? Role permissions. That means what she's permitted to do within the cloud space. If I click on that group, it shows me a group that she's attached to or involved with. If I go into our Azure role assignments, I'm going to see that that group has certain role permissions. In this case over here, Jane Doe has access to this resource called VM1 Network Route East. If I take advantage of another Azure portal screen right here, I can find out that particular IT infrastructure in the cloud. That is what exactly I'm looking at over here. VM1 network and all of that. I'm going to select that virtual machine, which in turn is a computer server. So Jane Doe should technically have access to this. I'm going to open up a brand new web page from Firefox, and Jane Doe is going to log in into our own account. If I go over here and I say portal.azure.com, and everything over here still stands the way it is, I'm going to go back to my original account. Remember, I'm the administrator, and I'm over right there, Skystack Holdings. I'm going to copy Jane Doe's credentials so that she acts like she's logging in by herself. I'm going to take some steps back over here. I'm going to come back to this perspective. I'm going to go to Jane Doe right here. I'm going to grab a username, and of course, I know what our password is. I'll copy a username, which is our email. Go back to our Firefox, put in that detail right there, hit the next button. It recognizes Jane Doe. Jane Doe is going to put in a password, and she's going to hit sign in. She has the multi-factor authentication that Promise was telling you about that has been set up for her. It tells her, I'm grabbing my phone as Jane Doe, I'm putting that out, and that is going to go through right now. So it has accepted Jane Doe's multi-factor authentication. I'm going to have her sign in. And now Jane Doe is signed in. And you can see right now, if I go to a place called All Resources to go and see how many resources Jane Doe can see, you can see she can see a lot of resources. This is because these resources are inside what we call a virtual folder in the cloud. The virtual folder has this much resources in there. That is about 11 resources. Watch what happens. If I go back to my own administrator account over here, now I am Scasta. I can go to my own page, go over to this virtual machine right here. She has access to this virtual machine, but this virtual machine is placed in a folder, just like the folder on your computer. And that folder is right here. It's called a resource group in the Azure cloud environment. I'm going to select that resource folder. I'm going to go to something that is called an access control. And I'm going to take a look at what she has access to right here. Wait for that to pull up. Says no result. That is not normal. So I was waiting for that to pull up. That is good. So I can see a lot of things going on over here. I can type Jane Doe's name, Jane Doe. It shows up over here. You understand? So she does have access to this resource group. Now I'm going to retract that role. You understand? That permission. I'm going to click on it and delete it. Now she no longer has access to the virtual folder that houses a lot of IT infrastructures, aka IT resources. That's what we call them in the cloud. I'm going to wait a little bit over here and I'm going to refresh this. Give it some time. See, you see that? Now she cannot see that much. She can only see a virtual machine and a disk. That is because I've just retracted her permissions. And that is using a technology called role-based access control to control what Jane Doe can see as well as what she can do. From this perspective, you've just seen what she can see and cannot see. You've just seen majority of the resources she could see just disappear because I just revoked those roles from Jane Doe. So that's how that works. Now, if I wanted her to have specific, if I wanted to see what roles she currently has right now, I can go back to my own page, go into my Microsoft Entra ID, which houses the technology for doing majority of all of these actions. I can go into users, see Jane Doe right here, select her, and then I can go back to our Azure role assignments to go and take a look. So you see right now, she has a few access to a virtual machine, which is a computer server, but she no longer has access to the virtual folder that houses much more resources that she can work with. And he also mentioned one other thing, which is your what? The different scope in which you can give people access to based on the principle of least privilege. That also correlates with another concept in identity and access management that we call what? We call it zero trust model or zero trust architecture. It means trust no one and give people only what they should have access to. So very, very important. In the Azure cloud, there are three main levels of scopes. For IAM, number one, the subscription. Number two, your resource group, aka the virtual folder. And number three, your resource, aka an IT infrastructure in the cloud, e.g., computer server, as we call it, or as we call it in Azure, a VM. So these are the three different levels. And of course, what happens is when you give someone an access at this high level, the parent, the hierarchy, it gives them access to all the virtual folders in your cloud environment, including all of the resources in your virtual environment. And so what he was trying to tell you is that when you give someone access at this, you point to a computer server, such as one of the ones we were looking at over here, which is in turn this particular computer server named this. They would only have access to these IT infrastructures. It doesn't matter if you have 50 or 100 or 200 IT infrastructures in your cloud environment. When you give them access to just this one, that is what they are going to be seeing from their own perspective. And identity and access management, working with RBAC, called the role-based access control, which in turn uses access control to drive role assignments, controls that notion. So he also talked about so many other cool stuff. So that is good. Now, I want to draw us back to something we're looking at in GitHub. We're talking about the concept of continuous integration or continuous deployment. From the code perspective over here, we are seeing the concept of continuous integration, having to put code project files that we wrote or we created in our local computer using a technology called Git. We use that Git version control to push the code project, right, to this environment called GitHub. And then other teams now have a central location where they can manage their code. That is the continuous integration part. Now, the continuous deployment part, as far as GitHub is concerned, the whole action happens, ironically, under actions itself. So I'm going to click on actions. I've clicked on it. And so you can see over here, there's a successful deployment of this to our Azure cloud environment. When I go ahead and click on it, it shows me more details. I can then go ahead and click on that again right there. And that shows me all the continuous deployment steps that Terraform takes to deploy that. It has all of these actions going on, including the master action here, the Terraform apply, that goes ahead and does what? Deploy the actual IT infrastructure to our Azure cloud environment. If you remember, and you're in this class, or this rather, not this class, but this S.H.I.F.T Hackathon, there is a workflow file, a YAML file that actually controls all of the commands. It is telling it that on the command of a push is when you make a major change in a DevOps environment. It means if I push a new change of a local file to a cloud environment or to a central location like GitHub, which is a repository area and continuous deployment environment, take note of that change. I don't have to come in here manually to do anything. Go ahead and deploy that change to the cloud or to a server. What it's trying to say is, if I have CNN.com and suddenly we have a new feature on CNN called voting or polling, right? If you're creating a vote poll and I create that new feature locally on my computer and I push it to this environment here, my continuous integration and continuous deployment will enable me to use this workflow file. This is a file that contains script commands to perform the next action. In this case here, I'm giving it a continuous deployment command to say on anything that is a push, which is a command we use like a script command, when someone pushes a local code change to this GitHub environment, go ahead and deploy those new changes, which means CNN.com now as the website, whether it's the one you're accessing publicly, from anywhere in the world, or a private CNN.com, a lower environment where developers and testers test things before they bring it live to you, right? Go ahead and push those code changes and make those code changes reflect on what? On the website that we have connected to this. So if I add that new feature, such as a voting poll, then if I push it from my local computer to this environment right here, based on this workflow file, will eject or will kick off continuous deployment to ensure that the website now reflects that new feature called the voting poll. And that is how that works, all right? One other key thing what I wanted us to look at is Splunk. Very, very important. We're talking about it from the theoretical perspective. Over here at Splunk, okay, so it's logged me out, that's fine. I'm going to log back in. That's a good security measure right there. After some few minutes, I don't think that was even up to an hour, it kicked me out. So that's good. I'm going to log back in. Go back in. So over here in Splunk, we've talked about Splunk is a CM and S, that CM is SIEM and SOAR, SOAR, CM plus SOAR. So it does all of those things we've talked about earlier on in the beginning of this, S.H.I.F.T Hackathon. If I go into the search and reporting, I can start looking at some certain commands I have over here. I'm going to close this for now. If I come back over here, I'm actually going to close this as well too. Then I'm going to try to launch this to see this guy right here. So if I look at this documentation right here, it teaches us how to use Splunk. We can start finding out things. Now, this Splunk system we are seeing right here, it has been configured to what? To monitor some 2 computer servers within an organization. Again, we're just simulating that idea of an organization. Let's say we're an organization. This organization, it is currently monitoring 2 computer servers, this guy and the other server that we saw earlier on. Over here, I can start running commands. You can see that right here. If I scroll down, I can see different commands. This guy right here, as an example, the index introspection. The purpose is to analyze Splunk itself, its health and performance. That is, I'm trying to see the particular tool that is actually trying to get, trying to monitor threats within my organization. How is the performance of that server itself? I can go over here, copy that command, come right in here, and I can post that right there. I have that there. I can even control the timeline. I say I want to see what you've been up to for the last 7 days. I can select 7 days, and I can hit that search button right there. And it starts to bring in different information. It has what we call a severity level in here. The severity determines the level of problem you are looking at. If the level of problem has a log level of info, that is not bad. That means this log level, I'm logging an information, I'm collecting information. That is the purpose of log. But the level of that log, based on the concept of severity, means how severe is this problem of item that you're logging? It says, no, it's just an informational log level. But this can go bad. This could be an error or severe or critical. In some cases, we term it as high, low, medium. High being the worst part. You understand? Medium being, oh, just okay. It might be a warning. Low meaning, no, it's nothing that big of a deal. It's just an informational detail. So that is very, very important. Let's quickly take a look at another example. As I go down over here, you can see that I have my host over here, my VM2 and my VM1. Those are my 2 computer servers that have been configured to work with Splunk using a concept, right, called universal forwarders. This concept enables me to configure what? Configure my Splunk with those servers so that Splunk can monitor them for threats and to monitor them for any problem, performance issues, errors, or any sort of Mitre, ATT, and CK attack. I can now go in there and say, I'm going to use this command over here. The index internal is something that Splunk uses to collect log data. As you can see in the description, it tells you that this searches Splunk's internal logs. That's why it has that word internal. And it filters the result to include only events from 2 specific hosts. These 2 hosts. The reason why it's doing that is because this command here says, when you go and get the internal log details, only focus on host this name or host that name. So when we grab that data or that information, basically always called a query, I can go back over here. I can paste that as well too. I can say this time around, I just want to know what's going on for the last 24 hours. I can select that, hit the search button, and it will show me. If it finds information for more than 1 host, it will let me know. In this case over here, is mostly getting for just 1 host. You know how I know that? I can just look here. Over here is capturing only 1 host. When I select that host, obviously it's going to tell me it's the second virtual machine or the second computer server. And so that reflects over here as well. And so that's pretty much what's going on. But because we're running out of time, I want to show us another key ingredient in here. There's something here we call dashboards. I'm going to go into dashboards. And in dashboards, we can create queries based off what? Based off our searches. Over here, I have one created over here that is called SCASTAC, Security Monitoring and Threat Detection. Let's take a look at that. So over here, what I've done is I've implemented search queries, the same search queries we were using over here, right? Under our search. We're putting in search queries in here, and it was finding data for us based on certain queries we're putting in here, and we're hitting the search button. Our dashboard does the same as well too. When I come into my dashboard and I take a look at this one, let me close this right here, and I come over here. If I take a look at this, I can see different dashboards. I can put it at the view perspective. So let me move this way. We might actually already be at the view perspective, and I can see different data visualizations. For some of us who are a little bit exposed to data analytics, I can see different features over right here. Right here, I'm taking a look at a command right here that monitors data folders. We talked about our universal folders in Splunk. Very, very key technology that enables us to configure and settings up that can expose all of the servers, systems, and everything, especially our host that we are monitoring. I can see that host. I can see the IP addresses as well too. I can see this is VM1. This ends with 145 and 157. If I come to my cloud environment and I go to VM1 over here, I can see that guy right there. That's my public IP. I can see that there. 4248.154.145.157. I come back over here, or rather over here, I can see that right there. The same goes for the second computer server we have in the Azure cloud environment. You can even tell us the last time he saw them online. And then over here, I have another visualization right here that shows me searches by, or search actions by users. It visualizes the users who are running the most searches in here. Right here, I can see myself right there. I'm the SC admin. Right here, this one, internal. This is by Splunk. This is the computer doing searches. It's doing the most search right here, 2,890. And me right there, 2,070. And then this one, the Splunk user, 1,289. So the visualizations are what? Part of what gives us more information about the search queries that we are working with. If I go back and I switch back to edit right here, I can come right in here and I can look at some of the key details. If I want to figure out what query was used to get this, I can click this. After all, I was the one that set it up. So I can click on the edit and I can see the Splunk search query right there. I can copy this guy. I can add back over to, let's say I think close one of that. Let me try to open this in a new page. I can go to our search and I can put that information in there and I can hit the search button right there. And that shows me the details right there. Now, based off the fact that this is a more advanced query using this kind of context over here, it's more like what we call a KQL query, a custom query language query. Bear in mind, there's another cybersecurity tool that is also a CM tool that is called ELK, the concept of Elastic, Logstash, and Kibana, also used as a CM tool. Also has something called KQL, but it's Kibana query language, all right? But this fantastic query over here that uses KQL technology, not talking about Kibana query language, but custom query language, uses this concept here, makes it more advanced that it brings it out under the result called statistics instead of our what? Our event. And so it shows me those details. But because this is not a data visualization screen, it breaks it down in a tabular format. Internal observability, SC admin, Splunk system user. When I go back over here, we see the same thing. That begins to show you the power of this board right here. And that is working because when I cancel this and I go back here, I'm choosing the bar chart. Look at that. I come back over here, the story remains the same. This one is looking at audit, is performing audit actions to see where the auditing coming from within our network of the servers, systems, networks, mails, and every other IT infrastructures we are monitoring. And it sees all of those basic levels, L subsets, edit local apps, all of these different areas. If I want to spy into that as well too, I hit this button, I can see it's a very simple query. It's performing an audit and is getting a statistical count by different actions going on, different audit actions. Again, the same thing. If I head back over here and I take all of this out and I put that in and I run that, I hit our search over here, wait for it. It brings out all of those key details, all of those areas it is getting its audit actions from. It's looking at things for like get password, delete actions, edit actions for users, else edit actions, all of those key things. So that's how all of those technologies work. Now, before we round up over here, we mentioned some other key CM and SOA tools such as Microsoft Sentinel. When we're looking at Splunk, Splunk is more on the on-premises, even though we're looking at Splunk Cloud, right now on Splunk Cloud. You can see it right there. It's using it's using a computer server to host an account for us so that we can use. If I go back to our Azure Cloud environment and I go to my home page and I click on security, once that loads up, I click on more services. Wait for that to pull up. And then I go under security. It's a cloud category, very, very important. From a cloud security perspective, there are a lot of things that are very important here. Yes, identity, where we're seeing the concept of Microsoft Entra ID and all of those other cool stuff. There's networking, very, very critical, and then security as well too. And then we have something we call the Cloud Workload Protection Platform that uses Microsoft Defender as an endpoint detection response to target specific IT infrastructures in the cloud, such as our storage, our cloud storage, our databases, our container applications, our container web applications. This is when we deploy web applications using the technology called containers. You understand? It targets all of this particular, that's why it's called endpoint detection. It targets those endpoints. And those endpoints are cloud workload protection platforms. The platforms, which are the IT infrastructures that carry the most load within the cloud environment. But back to reality. Under security right here, if I click that and I click on Microsoft Sentinel, I can see Sentinel and I can see Defender for Cloud. Let's quickly take a peek at Sentinel. Let's wait for that to load up. When Sentinel loads up, I have to create something in here. So I'm just going to quickly do that almost like a magic. I'm just going to set something that's called a log analytics workspace, and it's going to quickly create an environment for us. I'm going to come over here. I'm going to throw this under this virtual folder. This is a virtual folder. It's like trying to create a file and it says, hey, I want you to put this under a folder. I'm going to come over here. We're just going to say LG Sentinel. Turn that to G. Canada Central, that's the location. It's a data center somewhere around the world. It's going to create that in. That is fine. I'm going to hit review plus create. It's going to check and validate that everything looks good and validation pass, no doubt. I'll create that. And as that is going on, we're going to multitask a little bit over here. I'm going to come back over here, go to my home page, hit more services, wait for that to load up. I'm going to go back to security. I'm going to launch Microsoft Defender for Cloud as well. So now we have our Microsoft Sentinel in this page. Our Defender is on the other page right there. The deployment has been completed. Microsoft Sentinel has created something that is called the log analytics that it needs, right? So that's good. I'm going to go back to my home page from this perspective. I'm going to go back into the same Microsoft Sentinel. And now when I attempt to create a new Sentinel, it has a log analytics that it needs. It's almost like a human being that wants to walk, but it needs a leg. I mean, apparently there are other ways to walk, but technically let's just look at it from that perspective. It needs a leg, it's gotten his leg. I'm going to hit add. And if you want to know what that does, that is another concept that helps with security in the cloud. It's able to collect logs from critical IT infrastructures and relay that information back to our CM, which is Microsoft Sentinel. So there we have it right there. So now it's telling me, oh, you know, I don't see any Microsoft Sentinel set up. Do you want to activate one? I'll say yes, activate it. It's going to activate that. While that is going on, let's take a bit of a pause. Let's jump back to Microsoft Defender for Cloud. Over here, I have a setting here that will make me expose everything I have under here. I'm going to click on that. I can see all of the settings in here. So within Microsoft Defender, we can start configuring so many features in here. As we go into this hackathon and we go into other monthly series, we'll be diving deeper into these areas, right? But for now, there are some certain things called your security posture, which means what's the posture, what's the current situation of your security in the cloud. That is pretty much what the security posture here is talking about. I've just selected it, it's going to load up. As you can see, it's telling me my security posture is 47%. That is not good. In a company, you want that to be in the 90s, 90-something percent. You understand? So I'm seeing all of the recommendations over here. We're talking about severity earlier on, right? Severity, different types of threat levels from the highest to the lowest that means nothing, right? So we're seeing all of those severities. So as I'm looking at those severities right there, I'm going to just quickly narrow the screen, come back over here, wait for that new guy to launch, new document. For that, pull that to the right. So I can see different severity levels, such as our eye. Come back here, give that a number. Our actually starts from critical, which is terrible situation, right? Critical or severe, and goes to high, and then from high goes to medium. So as we're looking at these severity levels, the threat level is lowering. You understand? And so whenever you're in a cloud security space or cybersecurity space, and you see what is called the severity levels, know that it's talking about the threat level that you are experiencing. So over here, I go to low. The not just means it can't evaluate any of that, right? But however, on a normal day, you can have info and low, or in some cases, info can also mean what? Can also mean low. So you have those critical errors right there, those critical stages, the severity level. So it's telling us there's no critical problem, there's no high problem, there's no medium problem, but there's some low risk. You understand? And those low risk, there are 27 of them. Me personally, if I was creating the system, I'll leave low and I'll bring in info, because sometimes a low threat might be different from an informational data. And that is how that works, okay? And so it's showing us all of that. And so if I look in here, I can look at my recommendations. I can click on that. I need to show me recommendations based on any threat I have. There's a whole lot of features right in there. And when I look at these features right here, I start seeing columns. Even as this guy is loading up, right? I can see if there were any attack paths, I can find them over there. I can find the affected resources, because we are looking at Microsoft Defender. It is an endpoint detection response. It targets specific threat areas. So it lets us know, whoa, this is the specific resource. You can see our first computer server there, the VM1. We can see the VM2 right there. And so we can see all of those things. And then if I click on them, I can start seeing more details. If it has recommendations, it will give us recommendations to fix the problem. You can see take action. It's telling us these are some of the things you can take to fix this particular threat, that even though it is low, because you can see that the risk level is low, even though it's low, these are still the steps to remediate this specific threat that you are seeing. Those are one of the key concepts of Microsoft Defender. When we come back to Microsoft Sentinel right here, I think it's pretty much loaded up well. It has a whole lot of concepts. Earlier, we were talking about the MITRE ATT and CK. We can use the concept of MITRE ATT and CK to work with threat intelligence here, so that whenever we receive threats and our system picks up those threat incidents, we can use our MITRE ATT and CK to map that threat with a particular ATT and CK. Remember, the ATT and CK is your advanced tactics, techniques, and common knowledge. Let's go and look at it. Wait for that to load up. Perfect. So you can see over here, all of those key items we talked about, the reconnaissance, the resource development, initial access. If I go to their website right here, and we go back to the home page, I will see all of those things: the reconnaissance, resource development, initial access, execution, persistence. Initial access, execution, persistence. It maps them out. I can now read anything on any one of them. I can map these things and use them what we call the threat intelligence, where we can create what we call threat actors, attack patterns, indicators, so many features in here that we can map to our MITRE ATT and CK. It's getting late, so I know, thanks everyone for hanging in here, but we'll wrap up over here for tonight, okay? So if you have any questions, or you have any questions, you can definitely feel free to ask. But again, remember, this was hosted by SCASTAC Solution. My name is Olu. This is our very first S.H.I.F.T Hackathon. The S.H.I.F.T is the SCASTAC Hackathon for innovation, freestyle, and tech, where we bring people together. Feel free to collaborate in here. If you want to present something over here as well, feel free to reach out to me. And if you want a full IT training, remember to reach out and look at all the different IT trainings we offer over here. Our IT trainings are practical, hands-on, very, very serious. We offer, at the end of your training, we offer a resume, free resume, unique resume build to follow what you've learned and your skill set in the IT training. We offer mock interview preparations. We also connect you to recruiters, and we also connect you to job openings. Even in our practical hands-on IT training, at the end of every week, we give you practical hands-on lab assignments. You see one of the guys that presented, Promise, one of my best students, very, very good. He was able to complete his IT training well. I think the lowest score he ever had was maybe 99% or something like that, because we give grading on those practical lab assignments. So very, very good hands-on guy. And so if you're interested in the full IT training, definitely feel free to reach out. You can reach out to me via 469-325-4670. You can reach out via email to techinfo@scastacksolution.com. All of those informations can be gotten from the website. You can go to the contact us page over here. You'll find a lot of details to find us on Instagram, find us on YouTube, to go watch some of our free videos on different IT training areas, and get a whole lot of knowledge. If you want IT consultancy, maybe you want to reach out. We have a free 15 minutes to 20 minutes thereabout, where you can schedule a free 20 minutes IT training with us, so that in case you have questions, you're trying to get a particular guide path in the IT field, we can provide all of that information to you. So hopefully we all learned something good. I'm going to send out the documentation, which is the PowerPoint slide for those who attended. It's a whole bunch of us in here that signed up for the S.H.I.F.T Hackathon. So I'm going to be sending that PowerPoint documentation to everyone as well too, and looking forward to you joining us in our August, S.H.I.F.T Hackathon, where we'll be going more deeper into some of these things that we covered today, as well as other newer areas in the IT field. All right. Thank you very much.